Okay, hi linear algebra, how are you? As promised, I wanted to derive the alternative version of the dot product, which is right here in black that we talked about in class. And I just found this derivation online and I pasted it here. And this will actually be a good first exercise in you all reading mathematical text or textbook and then gleaning what you need to from it. So I'm going to talk you through the proof here, and on the side here, on the right hand side, I also made some important notes and takeaways. And you'll find that, especially next year, if you go and take a math course, you're going to want to kind of exercise this skill, if you will, and see if you can read a mathematical text in an active way and then also glean that information that really is person specific. Okay, so the first thing you'll notice here is starts with a vector v, a vector w. Here is the vector between the two vectors, and here is the length, the vector rather, v minus w. And the first thing I make sure to ask you is, in this configuration, do you know where the head and the tail of vector v minus w should be? So just to be clear, right, this is vector v. If I'm adding negative vector w to it, I'm saying vector v plus negative vector w, correct? All right. And so you know that the resultant of vector v plus negative vector w is going to be initial point here, terminal point here. So do you know where the head and the tail should fall? The head and the tail, this vector should be right here. Okay. Sometimes when you follow a pre-done mathematical proof, there are things that you have to add in to make sure that you understand every facet of it. All right. So here's the picture, and what you'll see here is they're just referencing this length of the triangle is the magnitude of v, magnitude of w, and magnitude of v minus w. Okay, so first line, by the law of cosines. Look at this. This is saying nothing different than what you saw in trigonometry some years back. It's a law of cosines. Okay, specifically, side squared equals side squared plus side squared minus 2 side cosine of the angle opposite to this side C. But just notice here, right, the side v minus w squared is this green side equals side squared plus side squared minus 2 side cos of theta. This angle is opposite this side right here. Okay, and then if you follow here, it says, okay, just take this and hold this for a second, and then now observe that. Now this is very interesting. They're saying I could also say that the magnitude of something squared, in this case the magnitude of v minus w squared, is the same thing as v minus w dotted with v minus w. Okay, and I want to take you to the yellow here. All right, you'll understand this first line by understanding my yellow over here. Okay, the yellow here, if you just kind of walk with me over here, if you have a vector w, observe that the magnitude of vector w equals the square root of component squared plus component squared. This is old news. And you also know that the dot product of two vectors is equal to x component times x component plus y component plus y component. But in here, you're dotting a vector with itself, and you'll notice that w1 squared plus w2 squared is just the radicand of the magnitude expression. So we could conceive of a vector dotted by itself as equivalent to saying it is the magnitude of the vector squared. So the main takeaway is this. When you dot a vector with itself, what you get is the magnitude of that vector squared. Then you walk back here. So what we're doing here is modeling what it means to read a mathematical text, annotate where you need to, and make notes that are specific to you, which is going to be different from the person next to you. Oh, hi. Hang on, I'm finding a space for me to finish this. Okay, wonderful. All right, so so let's go back to here. So what that means, so this is really interesting, right? Okay, and what's interesting here is that when you learn something of significance, right? Like what's new for you / me, for us, and when I say us, I mean you, right? This is new. That's a main takeaway. I'm going to make sure I know that, okay? So now let's go back to the proof. So the proof was saying, right here with this line, okay? So it's saying v minus w dot v minus w is the same thing as v dot v minus 2v dot w plus w dot w. Circled the green, look away here. The main takeaway is the dot product distributes, okay? So the dot product does distribute just like multiplication distributes. So the distributive property does apply to the dot product. And when, you'll notice here, you take a vector dotted by itself, when you do the distribution, look at this over here, v dot v, magnitude of v squared. W dot w, magnitude of w squared. And then here is minus 2v dot w, right? And then it says equating these two expressions gives, and these two expressions, when it says equating these two expressions, the two expressions are these. This one, which is v minus w squared, and this one, which is also v minus w squared. And look what happens. When you say they are equal, which they are, beautiful things happen. Cancel, 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 cancel. 2's divide out, and what you get is dun 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 right here. Okay. I'm going to add to this, just because it blends seamlessly right now, is you also know from trig that the cosine of an angle exists between -1 and 1. Okay. So by substitution, since this is cosine, I'm going to insert that right here. Here. Okay. Compound inequality. Multiply all three parts, if you will, by the denominator. I get this. Okay. I'm going to take the right-hand side and just take the absolute value. Okay. Now, let's make sure we're okay with this. Taking the absolute value, if I take the absolute value, this entity is always going to be positive. And then here's the absolute value of v dot w, and it's right here. What this tells you is that the absolute value, notice this is absolute value, not magnitude, okay? The absolute value of v dot w will always be less than the product of the two vectors' magnitudes. This is called the Cauchy-Schwarz inequality, okay, the Cauchy. All right, so that was fun, and I hope that you got something from it. Again, this exercise here, I'm going to do more with you once we get into the final spring term, because frankly, you're going to need to exercise this skill. That is the skill of reading a mathematical text and gleaning what you need to from it. Okay, we're going to exercise this in the spring a bit more with some kind of structured assignments. All right, and that's the extent of the screencast. Have a good day and an unexpected but nice nonetheless day off tomorrow. Goodbye, seniors.